All right, we're going to look at some information about a normal distribution. And so right here we have a histogram or a dot plot that shows a normal distribution. And so what a normal distribution is it means that most of the values in our data set, so in our case, the measurements that you guys took for your tolerance blocks should be really close to the mean value. So here in the middle, we have most of our data. So most of our measurements should be really close to that mean value. And as you move, in this case, to the right on our histogram, there becomes fewer and fewer values that are very far away from the mean. And so the same goes for if you move left on our histogram. Very few of our values are far away from the mean value in the middle. And so that's kind of how a normal distribution looks. And so you kind of will be able to tell when you see a normal distribution because it will have this bell-shaped curve on it. And so if you plot your data and it has a bell-shaped curve like this, you can think of it as a normal distribution. Next part of this is if we do have a normal distribution like we see right here in this graph, we can make inferences about the data. And so if we take our mean value that's right here in the center again, and we add one standard deviation. And so this Greek letter here stands for standard deviation. And so if we take our mean and we add one standard deviation, and we take our mean and we subtract one standard deviation, 68% of the data will fall within one standard deviation of the mean value. Now, if we go from the mean value and we add two standard deviations and subtract two standard deviations, 95% of the values should fall within two standard deviations of the mean. And the same goes for three standard deviation. So if I take my mean and again I add three standard deviation to it, and then I subtract three standard deviation to it from it, 99.7% of our data should fall within three standard deviations of the mean. And so why this is important in tolerances is because if you know that you want a tight tolerance on a part, you could mathematically calculate what that tolerance should be. You look at the data that we collected on our tolerance block measurements and we calculated, we have done that. So we have our mean value, we have standard deviation, we've added and subtracted one. And so again, if this was a normal distribution, 68% of the values should fall between these two numbers. Two standard deviation, so in that case, 95% of the data should fall within these two numbers, two standard deviation of the mean, and then 99.7% of the values should fall within three standard deviations of the mean. And so that's kind of the application of what we did with our measurements.